Hi everyone, welcome to our meetup, Completable FUTURE Story of Broken Rules and Developer Spain. I would like to introduce you to our speaker, Zbigniew Sokolovsky. He's Associate Chef Software Engineer with 19 years of industry experience and more than 13 years as a Java developer. Today, Zbigniew will tell us a story taken from real life. I propose to go straight to the topic of our meeting. Feel free to ask questions in the chat. Zbigniew will definitely answer them at the end of the meetup. So
Mhm.
let's start.
Thank you, Lisa. So thank you to all guests, uh, and I will show you and tell you about real story, which was really causes a developer's pain. So myself and my team, and let's go. Let's start it. So. What is the plan for today agenda? So we will talk a bit about new but not so new because Java 8 has a few years opportunities. Then we will dive a bit deeper. Uh, what does it mean? Then I will show you how it works in really depth internally, and then we'll make a QA session. Let's start. So in Java 8, so a bit long time ago, introduced the so-called Completable FUTURE class, and few important things about that class. That this class, along with the future interface, also implements a completion stage interface, and uh, and it defines the contract for the asynchronous computation step and combination with the other steps. And this is a very rich API. It contains about more than 50 methods. It was enriched in Java 9, and it has all what a modern developer could, let's say, imagine if you are talking about features. It's not yet reactive word because reactive word was introduced in Java 9, but in Java 8, this completable future, and this is very, I think, a lot of promise. It takes a lot of promise because contrary to the old feature interface and the feature task, it has 50 different methods you can do whatever with that if you want. I would recommend you to, if you haven't seen this, to go to the Java doc and study it because it is really half of in promising. So it allows you to compose, combine, executing asynchronously, synchronously, handling errors, whatever you want. So it looks like a heaven, and it looks that it's pretty. I think it could encourage you to refactor your code to this new thing because it is so enticing. And this completable future class, as I told you, it is a future interface plus this additional completion logic, still very attractive. And uh, this completable future overcame some feature shortcomings. It is non-blocking, so it is pretty important in let's say modern world. Has ability to programmatically complete a future, allows error handling, which is very handy, and its ability to change several features. So you can do with that whatever you want. You can run some logic, you can complete the feature, you can run it on asynchronously on the certain executor service. You can, or in the main thread, or last but not least, ability to combine results of multiple features which run in parallel. Everything it's very promising. Let's take at the code. I took it from the net somewhere. It has a bug, so I think that someone will notice that it has a bug. The code is not very beautiful. It's rather crappy, but still, it is useful to show you how it works, or maybe to remind you if you have some experience how it works. So let's dig in for a second. We have this array list ABC. We are streaming it. First, all of this message from a list we are using as a complete feature. So this completed feature method returns completed future, which is it means it was finished with a result on its input. So A, B, C. Then we are applying it asynchronously on the default executor service, which makes this delayed uppercase. This is basically sleep with the random number and collects results to the list. And such list of these computable futures, we think to let's say to combine them and have the result combined at the certain one moment. So we are using this static method all off. We have this computable future, and we have some check and result done. Then we are in the line 12. You are joining results. It is pretty similar to get, which was used before, but it's a different. We don't need to, let's say, to use checked exceptions. So in modern world of these fluent interfaces, it is much more elegant, but the usage is, let's say, the same. So we are joining the result, and the result was empty. It wasn't empty for sure. So this is a bug, but still, this code shows a bit potential of this completable future. Rest of that you have in Javadoc. All in all, comparing to the old plain future and future task looks wonderful, and I was urged at certain moment to rewrite old code to this new great opportunity and features. So coming back for a second to this introduction to Completable Future, everything here is true. However, to make this is not so easy as you can think of it. The third box, what is stated here, it's not 100% true, and the whole presentation is about that, and that you cannot trust to what you read so easily and have some assumptions in your head, which our team used to have. Let's go. As I told you, that is so enticing, but it is basically a trap. This. And why? So while I'm implementing our service, I've read a few times this Javadoc. It is what I recommend you to read it out after time, or maybe refresh it. And because the letters are small, so I will magnify this, what I have this on the next slide to have better, bigger letters. And we can read that Completable Future implements future with the following policies. Sounds great in the beginning. Since, unlike future task, this class has no direct control of the computation, and that causes to be completed, cancellation is treated just like another form of exceptional completion. And I magnify bold that text has no direct control, because when I was started to using it, I disregarded this, what I put here in the bold letters. Just, while you're reading a lot, Java docs, day by day, hour after hour. So sometimes you're trying to be focused, sometimes you can disregard something. And this was a case. Another thing which makes me think, but again, I disregarded it, was this sentence which with the params. And again, to make it more readable, I magnified on the left hand side. So so this is a first sentence is copy from the Java doc, but the next thing is comment, which is crucial. I was reading it a few times, but I disregarded this as well. This value has no effect in this implementation because interrupts are not used to control processing. So I thought that there must be magic behind this. So if they do not use interrupts, probably they have another means, because this is a JDK. It should work as in normal plain future it used to be. So probably they implemented it in another way, maybe something smarter. Times passed, time flies. So from Java 5, when the features were introduced, so probably they have done it in the smarter way. But please remember that it's always good. It's not easy because you can easily, skip this fragment or do not understand or something or disregard. But this is a clear sign, and I will show you why, that this approach is not best, and you need to read sometimes documentation a few times and be careful. And now why? But before I will show you why and what actually happened, I will tell you about, let's say, this is oversimplification of our project, but here it is a bit crucial. And I will tell you why. This is simply, let's say, of course, our project was much more complicated. We have Kafka, we have different components already, but it doesn't matter. Here, for making a picture clear for you, it was that we had this Amazon ACS cluster, which was running as Amazon EC2, and for the logging purposes, we used Amazon CloudWatch. Why it is so important? Because all thing is remote, and while you can run it on your local PC, you can observe much better, much more things. But while if you are running on the remote side, then you are only thing which you can see is read logs, maybe see some metrics, but it is much more difficult than working on your local machine and debugging the code. After this introduction, this is a code. I'm not sure if you can see these letters. I tried to magnify. So shortly, I will show you in IDE. But to say, this is, let's say, part of this code which we inherited, our project, and there was a few assumptions. So it was in the main thread, there was another thread which was run, but only one thread. I stress it, only one thread. In this thread, it was run a supplier, a task, and this task has a put method. Put method is in the blocking queue, as you see, so processing queue is a blocking operation. And due this, let's say, this whole machine was supposed to work, we also implement this method stop to stop our processing and computation, because it's mainly about computation. What we obtained, how it was working. We run it in AWS, and we see that I will show you in code in a second, but real code, but it was something like this. We started process partition via producer one. Then we see normal operation in a log stream, but due that tasks were pretty heavy this time because we started to use some more heavy content, we wanted to cancel it. So as you see, if you have observed in the last slide, we cancel it programmatically. We see in logs that producer stopped gracefully, still great. Then we came to the, let's say, conclusion, let's restart the whole process. So we observed this again, that started process partitions via producer 2, second one, and basically nothing. It passed 2 hours and was nothing in logs, and it was a pretty dreadful. And we started to debug what actually happened, why it happened. It was, I will show you why, and I'll show you details, but till this moment it was working correctly. And it took us more than 2 weeks to figure out a cause. So it was for us, it was a pain because it was stressful. And for our customer, it costed money because we were providing a solution, but for some reason, it sometimes was working, sometimes not. And as I told you, the not funny thing was that after this second run, there was nothing in log. And you can wait. And the question was for us, because we use this heavier content than normally, than comparing to let's say, this plain test which we used before, we are not sure if the program was actually hung for some reason, maybe something with the data, or it was just slow. We could not say it at the very beginning. But to show you what we encounter, I will show you a project, demo project, which you can find on the GitHub. Here is the path, and I will maybe give it to the after. You can now check it or after the presentation, but let's go to the code and see a real situation. So basically, I will change it to because I'm aware that you cannot see it, the presentation mode. Now you can see it. I will show for myself for easiness this project view. The thing is pretty simple. We have some params because I will show you, I will compare two implementations. So CompletableFuture, which use this CompletableFuture, and almost the same code, which use futures, future tasks, whatever. So so it will be, you will see a plain comparison between both. I prepared it on the sake that you can be, let's say, eager to use this new API, new class, CompletableFuture, but as always, you have to deeply investigate and deeply rethink it is what you actually need, because maybe it doesn't cover your needs. And this is normal approach, but happy-go-lucky approach is, yeah, we have a new toy, which is wonderful and stuff, so let's use it. And this was a case, similar case. Let's take a look at this class, CompletableFuture demo. And I will try to explain it. So what I told you, that producer class was supposed to be only one thread, apart from main thread, of course, because main thread was doing something. So we would like to have another thread which will be producer for some task, it will be single thread. So the best solution was to use, in our mind, to use a single thread executor, which just assure us that only one thread is running. We started, let's say, kind of task. And here, for the sake of the presentation, I would like to show you that this task was run, and instead of blocking method, which would block forever, and for purpose of presentation, I just use a sleep method because it will emulate our, let's say, heavy computation. What is interesting maybe for you, if you haven't used CompletableFuture, is that you can run your task on chosen. So this is a task. So this is producer task, and you can run it on the default or not default executor. So in our case, we change this default executor to this single thread executor, make us certain that we are using maximum one thread at the time. And to be 100% sure, maybe to fulfill our needs, we would like to have this stop. So if the task is still working, we are trying to cancel it. And for the, let's say, to be 100% sure, we left it here true. We last log that processing stopped gracefully. Okay, still it's okay. And finally, we were stopping executor service. So to have it, as I told you, in the pretty nice way, gracefully, we does it in that way. It was our initial thought, because we didn't want to make it forcible. We would like to have some, let's say, elegant code that we are shutting down, then await for the termination, and that's that. And let's say initially, this shutdown method now was, for some reason, was commented out. This is also important. And I as I told you, I commented it out for demo purposes. Let's please make me run this code. I will run it. Hopefully it will run. Gradle is starting to build it. Compilation. Yeah. Let's wait a second. So it started processing. I can show you the log processing. And this demo was also, maybe I haven't mentioned it before, that it was about starting some processing and then canceling it. So eventually stopping it, because it was our let's say, target to have some stoppable operations. We could stop it, start it, restart it, whatever. And two interesting things happened here. First, if you see this await termination, which we used here, as producer executor service was terminated, it returns false. So it was unable to close in the timed manner. It was unable to close executor. But what happened actually with the application? You see that it went 1 minute and and almost 20 seconds, and it's still running. Nothing happened. Application hung. We don't know what happened actually, because it hung. Maybe it is processing something. We don't know. We see such messages in log. It is pretty, let's say, strange situation, but it hung. And I don't want to make you to waiting forever and did this, let's say, 2 hours or more, but you can believe me that it won't never stop. I will show you then why. But this is a heavy content and it haven't stopped. It is working 2 minutes right now. Let's stop it forcibly for a second, and let me change a bit parameters for our demo. As you see, it was starting process, processing, and stop, right? So right now, to make it more interesting, this presentation, let's change it to short time. This was what we were encountering. And now you have the same code, just it sleeps for the short time. And you see that it worked as expected. Everything was finished as we designed, as it was designed. Maybe we changed this code, we inherited part of this code, but still, everything was beautiful. And at the beginning of development, we thought that this code is working correctly, at least, till the moment that the task appeared to be heavy. Let's come back to this option and run it. So let's wait. As you see, again, false. And I won't stop it even. I will return to presentation, but you see that it was working forever, basically. And this was for us very frustrating because on the other content, our data, when this computation burden was much higher, it started to work like this. It hung. But why? What happened? Let's come back to the presentation. Let me return to this shortly. And it's normally, right? We are developers, we are people who like to learn, and we know that no pain, no gain. And here the pain was substantial. Some gains are also quite okay. And let's analyze a code a bit. So instead of the sleep, we are using this blocking queue put method, which is basically blocking method. So it was what was working, let's say, forever. It was a heavy, and we used as I told you, this new fixed thread pool to have only one thread, and again it is worth to read Java docs. So task let me read from the middle of this text. Tasks are guaranteed to execute sequentially. No more than one task will be active at any given time. And this is very important message from that because it explains why it hung. And here I can show you I can show you what was in the demo. So instead of this put method, we just use this sleep with a very long time. But as I remind you that we are trying to cancel it, and I can show you for a second. It still works. Nothing happened, and we started to analyze it. What happened? Why it hang? Oh, absolutely, we don't know what happens. So let's say we read eventually code, we read documentation, we let's say focus on this thing more carefully. Read all Java docs again. Now with, let's say, not so big trust as initial, because it should know this is Java JDK. So it should work, like a charm without any, let's say, superstition. You cannot be, you expect that if they implement something and it should work somehow, maybe magically, but still. So let's compare a bit code, which is, this is a bit code which is, let's say, below this, and you see old future task. So not only implementation, it is implementation of the cancel method from Java 5 and CompletableFuture, brand new. And as it was told in this Java docs, which I showed you before, that its main interruptive running is not used. Nothing. It's not stated here. Maybe there is a magic, but it's not. It is just ignored as it was stated in Javadoc. But contrary, future task, as you see, and if you know how multi-threading works and know how threads are working, you see that it checks, it uses, maybe to say it in general way, it checks from the interruptions. It's let's say it checks state of the thread and so forth. So it is completely different approach, and still it should work in the same way, because this is a future, this is a future. So this makes a world of difference. And this is a bit strange. So we read it further and carefully. And what was the conclusion? And this, let's say that this main interruptive running was ignored. We came to conclusion after reading carefully documentation and spent a lot of time that cancel method in case of the completable feature works in completely different way, and this is not a bug. This is design decision. It was intentional, because it appeared, reading documentation and reading literature and so on, that contrary to future, completable future is not bound to any thread. It is higher level abstraction. You can run it on the thread. You don't have to. You can run in main thread. You can combine the results from different executor service. You can do whatever. But it has a cost, and this is a cost that cancel works in completely different way, because you are not on the level of the threads. You are on the level of some of abstraction. So you can cancel computation, but you cannot cancel a thread. So coming back for a second to the code, and you see 7 minutes. So it works for a long time, and nothing happened. Really really nothing happened. What was going on? So we run some computation intensive method, and even though that virtually, and we see this in code, you see, processing stopped gracefully. We virtually stopped the computation. It doesn't mean, at all means, that the thread was stopped. Thread was not stopped. And moreover, the single thread executor, even if we run another task, from the point of view of the single thread executor, nothing changed, because the task which we run here was basically hanging. We have here a put method which was pretty heavy, and it was like this long time, and eventually there was no possibility to run another task, because from point of view this single thread executor, previous task wasn't finished. It was just hanging, doing something, and this sleep method was ineffective. Flag was ignored, and this is what actually happened. And I will show you to show a contrast with the normal implementation. Let me stop it. 9 minutes so far. 9 minutes so far. Let's change our implementation to the another one. As I remember, it was another parameter, future. Apply. Still, we have this very long time. And here it's the same class, but written in the, let's say, a bit more traditional way. So we have a future. We have again this new single thread executor. Nothing changed. In place of this very nice it was the supplier with a task. Now we have a callable. We have a task which is heavy, and the same, absolutely the same. Let me run it. I will run it. And you see that even though it was pretty fast, and right now it's in the and the sleep was for a very long time. It got this message method was called cancel, and it was working like a charm. So in this case it worked as it should. And now there is a question: should we not use this fantastic new word, which is completable future? No, we should use it, but we should be aware, and we should documentation enough carefully to understand these small things, this in the documentation, and read it with the sober mind, because we are, we are doing something, we are developing, we are in the hurry, and we think that we let's say we have a great ideas and so on and so on, but from time to time it doesn't work as expected. In this case, and I will explain it a bit further and show you one thing, that this cancel method was working in absolutely different way, and the philosophy behind the completable future and the old future is different. But here the lesson learned, and which you should take from this presentation is what I told you. So read it carefully, think it over, and if you are in the urge to change your implementation, think twice. Of course, I'm not telling you that CompletableFuture is bad, because it's great. It has a lot more than this future task, old plane. But you need to be very cautious and be aware that if you use this cancel method, it won't work. It will work in a different way. So you need to redesign it. It is something, let's say, different. So this is a great lesson. And to show you, because first we had a, let's say, kind of urge to, let's say, to change the implementation to the old features, but you don't have to. And in our, at least in our case, so I will show you what theoretically could help in this our case, of course, because your case could be different. So basically, let me uncomment this code, because what we could do, because every time we were starting a new thread executor, because this was a very rare occasion, so we could afford that from time to time we could completely shut down our executor and start it from scratch. I don't know if you could do the same, apply the same approach in your project, but we could. And to avoid refactoring, to avoid everything, we just add this shutdown now. Let me show you. Let me show you for a second. So let me change to completable again. Completable, and run it. As you see, it stopped. So it worked as we expected. It is not elegant. It is, maybe you can avoid it, but in our case, we just shut down it forcibly. So it was, of course, not terminated because it hanged. It was cancelled, so task was finished, but thread was hanged. But we can shut down this executor and again start another task with a new executor, and it will work for our purpose. However, as I told you, this is not so elegant solution. Let's come back to let me for this, let me comment it again and return to presentation. And this may be to state it again. So CompletableFuture is not inherently bound to any thread. It is higher level abstraction used for computation, but higher. Future was our future, which we used for years. I'm seasoned developer, which is 4 years, was representing background task. It was representing a thread. This is something different. So please be careful when you are using new toys from SDK. And now to let's say to what actually happened, what they did in JDK. So all of us, let's say developers, should know solid principles, because they are important, very important for us. What JDK designers did was that they break Liskov principle. What does it mean? If as, let me read it this one time. If as is substitute of T, then objects of type T may be replaced with object of type C without altering any desirable properties of that program. And this has a deep sense, but in this concrete place, it is not working. And we thought that, yeah, we have another features, so it should work in the same way. It was our assumptions. So if we want to stop it, it won't be stopped, even if they saying in the Java docs that this may interrupt if something. This mean that probably they change it, so somehow the magic is behind whatever, and it will stop. And no one figured out initially that the change was so deep that this design that they will break a so important principle. And it costed us literally 2 weeks to figure it out, to read documentation, to think it over, to test our code, what happened. And the result of all this thing is here, this presentation. Right now I can show you some references. The first one is article from Java champion Polish Tomasz Nurkiewicz, and this article is, as you see, from 2015, so it was a long time ago. He explains the same thing what I showed you before a while. So someone encountered it, and that this was Liskov substitution principle was broken. If you want to dig it more about Liskov, so you have this wiki article. And to make you, let's say, disregard this completable future, because it is very useful in some cases, then I also added this 20 example of using completable future, and I hope that you will find this link, especially this last one link, useful, because you can, if you do this in the smart way, you can leverage this new class very nicely. So it's basically last slide, and this is a time for the Q&A. I can answer your questions, hopefully, and please ask me a question.
Thank you very much for the topic. We don't have any questions yet, but we have very large comment from Alex Taranovsky. Thank you for following the process carefully, and thank you for your feedback and suggestions. This is a pretty big comment, so I think that maybe Zbigniew, you will read it by yourself and maybe give some comments. And when we will have another questions, we will go to them. Okay?
I am reading from Alex Tarnowski. So far you are describing a trivial Java threading problem identified like more than 10 years ago. I don't know what are you meaning. So I will gladly to hear you. I guess never use internal Java mechanism like interrupted exception. It gets messy there. I think that interrupted exceptions we are using in normal Java code frequently. The thing with this threading problem was, I know, as you see, article was from 2015. And you shouldn't use that in the first place. Okay, so but if there is a public API and we have SDK, so I think we can use whatever we want. We can just use it badly, and it was the case. But you know, things like this happen. Of course, someone can have different approach, and the whole presentation was not only about let's say concurrency and stuff, but as well about carefully reading documentation with understanding. So maybe not in this concrete place, but in another place, someone could encounter a similar issue or will encounter in the future. Because this shows that even though that all of us know solid principles and stuff, not always you can believe it that everything was done as you think. And this was only to show you not a trivial, as you told us, concurrency thing, but not so obvious that sometimes it needs some documentation to be read carefully twice, 3 times, and if something does not add up, return to it and try to understand it. Why? Okay, so there are another comments about how Alex suggests the code, which maybe is worth to let's say to review it, but maybe not now. Okay, let me read it down. Quick internal thread pools were not close. Yes. Okay. Okay. So this is, I think that this is kind of tips from Alex, and we can discuss it. I think because I think it is a long discussion about GC. And remarks like programs usually don't magically hang. We know it, but it was not so easy to figure out why. Not all public APIs, even Java, are good. Yeah, and this is a case that sometimes those not all APIs are good, and this is to bring someone attention. Great that you, Alex, you are aware of that, but I'm afraid that not everyone is aware of that, and we are using something like Java SDK as rock stable and rock solid. So this is just a reminder to be sober. I think now from Darko Dalla Vecchia. I think that ComplettableFuture component stage has a big downside in all API all returns values, which all have ComplettableFuture with other result. It is, I think, it is just because they would like to have these fluent interfaces, and if you would like to have this future interface, this is why they are, most of them have this completion stage, because as I told you, the whole enterprise was used that you can combine different computations, from different executors, from different ways. So you need this completion stage to make something different, and you can, using that fluency, you can do basically whatever you want. You can, it is, only by your imagination what you can do with that. You can do something magic, let's say magic, or it could be, you don't have to be so nice, but it's still it, because it returns the same thing. You have this fluency, fluent interfaces with you, fluent methods, so you can do whatever you want. So you have a lot of options. Trivial, it was described in well-known book. Yes, I read that book as well. I think that all developers that book. Thank you for recommendation for that book. I think that I agree with you that all mature developers should read it out. So thank you. Thank you, Alexander Padro, for that. We find you if you found it interesting. And I agree with Alex again, Taranowski, that nothing is perfect. Yeah, and this is clear show and eye opener for you, for audience, that is not perfect. So this is also why this presentation was created, to show you that is not so perfect. This was the purpose of this presentation. With such cases, does Java GTK provides another API dealing with similar use cases? For example, I think you could use, but still it is partly reactive programming. So as well, it comes to me easily, or you can stick to the old plain Java features, and it will make this job, as I told you, as I showed you, because it was, and you would never realize that probably that something like bad like this will happen, but it happened. Exception can mess up internal state. When you handle interrupt exception, you can mess up. Oh, probably yes. Thank you guys. Thank you guys for your listening. Thank you.
Yeah, thank you, everyone. We haven't got any questions, so I think that we can finish our meeting. Thank you all. Please share your feedback about the event, vote for the topic on the event page, and give a badge to the speaker using the Say Thank You button. The link will appear in the chat soon. But we have one more question. I think that we have time for only for one question.
Okay.
From Anton Sweetin.
Okay. So in particular case, would be a way to handle the situation in a more elegant way. Yes, just to elegant way would be use this plain old feature. One thing, or maybe rewrite it completely to maybe to have some reactive code. But it would be time consuming. The issue is that when you're under pressure, like us, and client wants to have solution very fast, and we let's say added this CompletableFuture to library which we inherited from another project. We need to have results SAP, so as soon as possible. This why this not so elegant approach was used, just to to satisfy a customer. Otherwise, it would take, let's say, maybe one additional day, which could be unacceptable. So after short thinking, it was a decision to write like this and do not change all that code because it was working. And we knew that that it will be this closure shutdown now of the executor would be only from time to time, very early. So this solution would pass in the crowd.
Okay. I think that our today Tech Talk is finished. So thank you everyone for your activity. Have a good day.
Thank you. Likewise. I wish you a good evening,
Yeah.
afternoon.
Goodbye.
Goodbye.